Hi everyone. Today we are going to see about crashing. Okay. For that crashing, I have taken a problem from December 2024 question paper. Okay. That is illustration number. That is the problem number 7. Okay. This is from the question paper December 2024 SCM question paper. Okay. The crashing is similar for inter and final, but this is the final question paper question. Okay. The first step in crashing uh, is network diagram. After that, critical path. What is crashing? Okay. The what is crashing means we are going to reduce the duration of the project. That is called crashing. We are going to crash the time duration of a project. That is the main thing. Okay. For that, uh, what are all the steps involved in the crashing? Okay, step by step we will see what is crashing, what are all the steps involved in the crashing. Like that we will get into this problem. Okay. Rontech Limited, an engineering firm, won a contract to install an instrument landing device at the local airport. The complete installation had been broken down into 7 separate activities. Each activity is procedures activities, normal time, crash time, normal cost and crash cost. Everything has given. Okay, given in the table. What we need to do, what they require. What is the requirement means we have to design the project network and indicate all the paths through it and assess the critical path and the normal duration. Evaluate the percentage increase in cost to complete the project in 21 days. These are all the things they have asked. Okay. So first thing is network diagram we have to draw. Second step is we have to find out the critical path and its duration. Third step is the increase meant in the crashing. Okay, what is the cost of crashing? Okay, because of that, what is the effect in the percentage increment in cost to complete the project in 21 days? This is the goal. We have to crash the project to 21 days. Okay, let's see. Let's get into the problem. The first step is network diagram. Okay, for that they have given this in this table. They have given the data for network diagram, the activity, the procedures activity and its duration. These three, from these three data we are going to draw the network diagram. So always network diagram for crashing we are going to take the normal duration only. Okay. Okay, what is the network diagram we need to draw from A? Okay, we know how to draw the network diagram. I already explained in the previous videos, network analysis videos. I have explained how to draw the network diagram. Okay, from that, here A activity, for that the activity node is from 1 to 2. For B activities it's for 2 to 4 and C activity is 2 to 3 and D activity is 2 to 5 and E activity is 4 to 6 and F activity is 5 to 6 and 6 to 7 is G. Okay, and its procedures activities are given by using this procedure activity we have placed the position of the network diagram, because for these two B, C, D and B, C and D, all the three, A is the predecessor. Okay, for D, what is the, for D, sorry, for A, B, C, A. For E, what is, for E is B and C. So for E, B and C. So this is E. Okay, then starting point of node is E is 4. Okay, 4 to 6. So its precedence is B and C. Okay, this is B, this is C. So this has to join. So for that we made one dummy line. So B plus C, the starting point of E. So B, this is the C is joining through this dummy. Okay, like that for F activity 5 to 6, the activity for the C and D, the preceding activity is C and D. Okay, for C, this is C, this is D. So through this dummy, the fifth node, the starting point of F, through this dummy C is connecting to the node 5 for for the starting point of F. And 6 and 7, the activity of the starting activity of G is, the preceding activity of G is E and F. So E and F. Like that we have finished the network diagram. Okay. For that, each and everything, the corresponding time duration we have to enter. Okay, for A7, for B4, like that we put that diagram also. So we complete the network diagram. After this step, what is the next step? Usually network diagram, critical path. So for critical path, to find out the critical path, we are going to write all what are all the paths available. What are all the paths available in this network diagram? Okay, for that I have selected first path, that's A, B, E, and G. A, B, E, and G. Okay, from starting to ending node. A, B, E, and G. This is one path. Okay, through this path, one path is there. A, C, F, G, another path. A, C, this is dummy, so there is no nil, and F, G. Okay, and A, D, F, G. This is A, D, F, and G. A, D, F, and G. This is one. A, C, E, G. A, C, through dummy, E and G. Okay, this is the path. Okay, for that, each and every path we are having corresponding duration. For A duration is 4. So A duration 4, B duration is, sorry, A duration 7, B duration 4, and E duration is 7, and G duration 6. Like that, for every path I have written the duration. After that we have to return the duration. After that, the total number of days. These are all in days. Okay, these are all in days. As per the question, this is in days. Okay, the total number of days available is for this path is 24, second path is 23, third path is 24, and fourth path is 25. So from this, what we have find out is the fourth path, A, C, and E, and G, is the critical path, because the maximum number of duration is involved in this path. Okay, because it is taking long time to complete the project. So A, C, E, G is the critical path. So we find out the critical path. So second part of the sum also we have done. Assess the critical path and normal duration. Okay, so its normal duration is 25 days. Okay, now we are entering the crashing step. Okay, in this project, the maximum number of days as per normal duration will be 25 days. Why? Because all other activities are involving lesser number of days, but the activities involved in this path is having higher number, that is maximum number of days. So the maximum number of days taken to finish this project is 25 days. So this is the maximum duration for this project is 25 days. So the critical path duration is the maximum number of days for the project. Okay, that is 25 as per normal duration. What is our motive? So what they have asked, the third part of the question, evaluate the percentage increase in cost to complete the project in 21 days. Okay, so our motive is to crash 25 days to 21 days. So our motive is to crash from 25 days to 21 days. So the percentage increase in cost to complete the project in 21 days. That is the question they asked. So our goal is to crash 25 days to 21 days. So 4 days we needs to crash. For explanation purpose, I written in simple language. Okay, 4 days needs to crash. That is the thing. So for that, what are all the things we have to do? First one is cost slope. We have to do the cost slope. Formula for cost slope is the change in cost divided by change in time. Change in cost. Change in cost is crash cost minus normal cost divided by normal time minus crash time. This is the formula. So I simply say change in cost divided by change in time. Change in cost means this normal cost and crash cost. So here crash cost is higher. So 900 minus 500. So 900 minus 500 divided by 7 minus 5. Okay, 7 minus 5. So this is the cost slope. By using this formula, we are finding the cost slope. Okay, this is the cost slope is nothing but for each activity, how much is the crash cost per day. Okay, like that, for reducing a activity by 1 day, how much amount of money we need to spend. That is called cost slope. That is the simply we can say this is the thing. The cost slope means the amount, okay, the amount need to reduce the activity by 1 day, per day. Okay, per day how much is the amount required to reduce the activity. That is the thing, that is called cost slope. Okay, For that, this is the formula. So I simply say change in cost, the amount which is the difference, okay, the difference in cost divided by difference in time. By using this, okay, for cost law we are going to make one table. This table it's very simple. We can just write like this: activity, normal cost, normal days, crash days, normal cost, crash cost. Like that we just take those things, okay. This till that the same thing. After that, the cost slope, okay, the cost slope is this formula, the change in cost divided by change in time, okay, change in cost divided by change in time. What is the change in cost here? 400. Change in time is 2, so 400 by 2 just 200. Like that we have to find for every activity. Here the change in cost is 200, the change in time is 2, so 100 per day. For this activity, per day cost is 100. This is the thing, okay. Like that for each activity we have find out the slope. And normal cost I have put the total because we required, because for percentage change in cost we have to find out. So for that we need the total cost, so that is normal cost. So crash cost, cost slope is over, okay. This is number of days available for crashing. This is for my understanding. I have added this thing also. It definitely it will useful for the next step. So in that, for each activity how much days available for crashing. So we need to crash. The normal duration of A is 7, the crash duration available is 5. So the difference we can crash up to, so crash after crashing 5 days should be there. So the 2 is the available days to crash, okay. Here in B activity something is wrong in the from question paper itself. So how we can crash? The normal duration is 4. How we can crash up to 5 days? I don't know. This is wrong. So here I take it as nil only, because the number of crash days available here is -1. This is not right actually, because normal duration itself 4 days. How we can crash up to 5 days? I don't know. Okay, here we can crash, normal duration is 5 days, crash up to 5 days, okay. Here the crash day available is 0. Here normal duration is 6 days, we can crash up to 4 days. So up to 4 days mean we can crash 2 days, okay. For this here we can crash up to 3 days, we can crash up to 3 days. Here for G we can crash up to 2 days. This is the number of days available for crashing. This thing is done. This is the cost loop, okay. From this we are going to the cost of completing the project in 21 days. Let us crash that activity on the critical path, okay. We are going to start the crashing activity from critical path. Why? Because critical path is having higher number of days, maximum number of days. So we are going to start the crashing from critical path to complete the project in 21 days, okay. Here in step 1, here for that I also, this is for understanding purpose and for explanation, I have made one more table. This is completely for understanding purpose. I have put all the paths A, B, E, G, the same paths already I have explained. 4 paths we have determined through network diagram, all the 4 paths, its duration, okay. After that, first step, second step, third step and fourth step I have made it as a table, but in exam you write it okay, detailedly you have to write it. This is completely for explanation purpose, for understanding purpose only I made the table. Here in step 1 what we are going to do, here you see this is the critical path, right? This is the critical path. Here we are having 4 activities, A, C, E and G, okay. A, C, E and G. Among these activities we have to start reducing the days from these activities, okay. Among these 4 activities we can start the crashing process, okay. First step what we can see, the cost slope is nothing but crash cost per day for each activity, okay. The crash cost per day for each activity. We have to see the minimum amount, okay. Which activity is having lesser cost for crashing. Here we can see D and E is having very low amount. So among this E is present in the critical path. So we can start from E, okay. We can start reducing from E, okay. We are going to reduce E. How many days available for E? 3 days. Okay, 3 days we can able to crash, because this is this much days only we can able to crash. More than that or that we cannot do. Okay, so 3 days are available for crashing purpose. So from that, what we are going to do, we need to reduce 4 days, right? We need to reduce totally 4 days. So if you reduce 1 day, okay, if you reduce 3 days means what will happen? Here it will become 22. Here it will become, here there is no, okay, E is not present. So it will be 24 only. Here E is not present, 23. And here E is present. Okay, so you are going, if we are reducing 3 days means it will change into 21 days. Okay, but what happened means here it is 25 days to 22 days, but this is the critical path. The main motive, main point and the important thing we have to remember in crashing, it's a very important thing we have to remember in crashing is we should not, the critical path, we should not reduce the critical path duration, because the once if you identify this is the critical path, always this should be the critical path till the end of the problem. Okay, all we have to, this status, the critical path status of ACEG should not get lost at any course of time. Okay, so if you reduce all the 3 days of E from this, it will change into 22 days. Okay, but after that what will happen, this path, third and second path is having more number of duration than this critical path. So this path's criticalities got lost. Okay, it is lost. So the status is lost. That should not happen. So because of that, what we are going to do, if you reduce, okay, if you reduce to 2 days, 2 days if you reduce means here it will become 23. But here it will become again 24. So it will be more than this. So the critical path status is lost. So because of that, we are going to do reduce 1 day of E. Okay, if you reduce only 1 day, then the critical path status of this path will not get lost. Okay, will not get loose, it will not lose its criticality. So we cannot reduce 2 days or 3 days of E. So we can reduce, because if we reduce more than 1 day, the critical path status of this path will get lost. So we are reducing only 1 day. This is the first step. Okay, we are reducing 1 day. Here E is there. So 1 day is get reduced 24. Here there is no E activity, no E activity. Here E activity is there. So from this it is getting reduced to 1 day. So 23. So it becomes 23 days, 23 days, 24 days, 24 days. So the critical path status is maintaining in this path. Okay, next step what we are going to do is, next step, what is the, here these two path is having the same number of days. So what we have to do, we have to find out the common activity to get reduced, because if you are reducing some other activities means again critical path status will get reduced, right? So because of that, we are going to reduce the common activity present in third and fourth path. So here what is the common activity present in this path is A and G. So from A and G we can reduce the days. Okay, we can crash the days. Okay, so for that what we have to see is that crash cost, how much crash cost we need to inquire for the crashing purpose. So if you reduce if you taken G as for crashing means what will happen, we have to inquire 400 rupees, but for A it is only 200. So our motive is always cost reduction, right? So we can take A. So the common activity present in A, these two paths is A. Okay, we can reduce, A is present in all the paths. Oh, so the number of days available to crashing, available for crashing for the A activity is 2. So we can reduce 2, because if you reduce 2 here means in all the activities A is present, so all the path A is present, so everywhere it will get reduced. So there will, the critical path status will not get affected by the fourth path. So it will get reduced in all the paths. So here 2 reduced, here 2 reduced, here 2 reduced, here 2. Now this 2 becomes equal again. Okay, but we need to maintain the critical path status of fourth path. So for that what I am going to do, what we are doing here, it is what is the activity. First we need to, here both are having the maximum number of days, no? So now we can take this path. Here D is present, A or G is also present, but G is having higher so D is the unique activity which is not present in the other path. So we are taking this D activity. Okay, the cost inquired for D activity is 100. So the number of days available to reduce for D is 2. Okay, crashing day is 2. So for that we can reduce 1 day in the path 3. Okay, the D is not present in other activities, so we are reducing we are taking the critical path status of the third activity, because we want only this path should be critical path. So we are reducing the days of this critical third path. So for that D activity we are taking. The D activities crash cost is 100 rupees. So by reducing 1 day by D, it will get into 21. So all others are 21 and fourth path is 22. All others are 21 and fourth path is 22. So here the step 3 is over. Okay, and step 4. Step 4. Now what is our motive? This critical path's duration has to get reduced to 21 days, right? So we need to crash one more day in this. So we need only one more days to crash. Okay, for that we are having G activity in all the things. But what is the problem here is, G activity's cost is higher. So instead of that, what we can do, we can reduce E activity. C we cannot take. Okay, A already over. C we cannot take because there is no days available. So only thing available is E, because G is higher cost, E is lower cost. So we are taking E. So by reducing, we need to reduce only 1 day. So by reducing E by 1 day. So E is present in first path and last path. Other two E is not present. So first path will get reduced by 1 day and last path, that is critical path, is also get reduced by 1 day. Okay, here A is already over, G is having higher amount to crash and C we cannot take. Only E we can take. For E we are reducing 1 day. So by reducing 1 day, the first path is reduced to 1 day and last path, that is critical path, is reduced to 1 day by 21 days. Our goal is achieved. Okay, the goal is achieved of 21 days. Okay, we reduced the project timing to 21 days by reducing the time in the critical path. Okay, final step, we are going to find out the crash cost amount. Okay, we reduced, in the first step we reduced E by 1 day, that is 1 day, and second step A by 2 day and D by 1 day, third step, fourth step again we reduced E by 1 day. So what happened, the cost of E is, crash cost of E is 100, A is 200, D is 100 and E is 100, same E. So into number of days we reduced. So from that we inquired 700 rupees. This is the total crash cost we inquired for this project. Okay, in order to complete the project in 21 days, an additional cost of 700 will be inquired. Okay, so normal cost of the completing the project is 25 days. Normal cost is this much, that is 4,500. Okay, but we inquired more 700 rupees. So among the 4,500 rupees, we inquired more 700 rupees. So the percentage increased is 15.55%. So the percentage increase in cost to complete the project in 21 days is 700 divided by 4,500 into 100. Okay, this is the percentage. That percentage also we have find out. We have find the percentage of increase. Okay, simple. Normal cost is 4,500. Extra cost we have inquired is 700. So total cost is increased to 5,200. Okay, at first it was 4,500. Because of crashing, it has increased to 5,200. So how much it is increased? Now instead of 100%, now 115.55%. So increment is 15.55%. So increased because of crash cost. So that only we have find out. So till this the sum is ended. This is for explanation I have done. Okay, this is the end of crashing. Okay, please subscribe my channel. Thank you.